Hello students, welcome to the online session of database management system. In previous session, we have studied about concurrency control in database management system and the concept of locking. In database management system, we have two types of lock: read lock, that is shared lock, and write lock, that is exclusive lock. Shared lock is compatible with another shared lock, whereas exclusive lock is not compatible with any other lock. That is, if any transaction want to perform a read operation on any table or on any data item, then that transaction may request for read lock on that data item. Then transaction can perform read operation, that is transaction can execute select query on that particular data item or on that table. If any transaction want to perform any insert, update or delete operation on any table, then that transaction can request for exclusive, that is write lock on that particular table, so that transaction can perform select, insert, update and delete operation on that table. Okay, so this is the concept of locking, and in previous session we have also studied how to apply lock by using MySQL editor. Okay, now in current session we are going to study about lock based protocol types, that is two-phase locking protocol and strict two-phase locking protocol. Then we are going to study about the problems in simple locking. The learning objectives of today's session are: after learning this session, students will be able to describe the problems in simple locking, and students will be able to describe two-phase locking protocol. Now, simple locking concept in DBMS is where transaction just demand for the type of lock. If transaction want to perform read operation or select operation, then it will demand for shared type of lock. And if transaction want to perform insert, update or delete operation, then it will request for write type of lock. Okay, so this is called simple locking technique. But there are some problems with simple locking technique. The first one is deadlock. Okay, now see, two transactions are given in this figure, transaction T1 and transaction T2. So first we'll see what is deadlock. Deadlock is a situation where two or more transactions or processes are waiting for each other to release locks on data item, and none of them can be proceed to completion. So simply in deadlock situation, when more than one transaction want to access a same data item, but they could not access those data items because that data item is locked by some another process. Okay, so here in figure you can see there are two transactions T1 and T2. Here T1 transaction holds an exclusive type of lock on A. Okay, means A data item is locked by transaction T1 using exclusive lock, and at time cycle 5 T2 is requesting shared lock on same data item, that is A. Okay, but that A data item is previously locked by transaction T1 in exclusive mode. Okay, and exclusive lock is not compatible with shared lock. So though T2 is requesting for shared type of lock, T2 has to wait till T1 releases the lock on data item A. Okay, similarly T2 is holding shared type of lock on data item B. Okay, and at time cycle 8 T1 is requesting exclusive type of lock on same data item, that is B. Since B is locked by transaction T1 in shared mode, okay, T2 is holding shared type of lock on data item B. So now T1 has to wait for T2 to release the lock. Okay, so in this situation neither T1 nor T2 can proceed the transaction because T1 is waiting for exclusive lock on B, but B is locked by T2, and T2 is waiting for a shared lock on data item A, but A is locked by T1. Okay, means none of these two transactions can proceed their execution. So this is called deadlock situation. And to avoid this deadlock situation, any of T1 or T2, means either of these two transactions, need to be rolled back. That is, we must roll back any of these two transactions, or any of these two transactions must release any of the locks, so that at least one transaction can proceed its execution. Okay, so this is the deadlock problem that frequently occurs in simple locking protocol. Then next problem in simple locking is starvation. So starvation is a situation where a transaction process or a process has to wait for longer or indefinite time period to acquire a lock. Okay, means the waiting period of any transaction for acquiring any lock is very longer, or it is indefinite. For example, suppose T1 transaction is there, that T1 transaction wants to acquire exclusive type of lock on any data item. Okay, and on the other hand, number of other transactions repeatedly request and get shared lock on the same data item. Suppose one student table is there and T1 want to acquire write lock or exclusive lock on that student table, but number of other transactions are there that want to access student table by using shared lock. So shared lock is compatible with shared lock. So if number of transactions are requesting shared lock on that student table, then all those transactions are getting permission for that shared lock. On the other hand, T1 is not requesting for shared lock. T1 is requesting for exclusive lock, and exclusive lock is not compatible with shared lock. So T1 transaction needs to wait for all other transactions to complete, and T1 has to wait for all other transactions to release the lock. Okay, so there will be a longer or indefinite time of waiting for transaction T1. So this is called as starvation situation. Okay, and to avoid this starvation situation, we need to design concurrency control manager in good manner. Okay, so these two are the deadlock and starvation. These two are the problems that frequently occur in simple locking protocol. Now we'll see what is two-phase locking protocol. Okay, two-phase locking protocol is also called as 2PL, and it is mainly used to ensure serializability. Okay, means it is used to ensure that though we execute different transactions concurrently, they will produce same result as that of serial schedule. Okay, that is called as serializability property. Okay, in two-phase locking protocol, transaction is executed in 3 steps. So in first step, transaction request lock. Okay, means transaction send lock request to concurrency control manager. In second step, it acquires requested lock and it start performing operations. Okay, so this is the second step. And in third step, transaction releases acquired locks. Okay, so in 2PL we have 3 steps of execution for any transaction. In first step, transaction is requesting for the lock. In second step, transaction is acquiring lock and performs operation. And in third step, transaction releases all the acquired lock. And once the transaction release its first lock, after that it cannot hold any other lock. For example, if transaction T1 is there and T1 is holding 3 locks on different data items. So in third step, once that T1 transaction has released any of these 3 lock, then that T1 transaction cannot request for new lock. Okay, means before release of any of the locks, transaction can acquire new lock, but after release of a single lock, after release of a first lock, transaction could not hold any other lock on any of the data items. Okay, so this is two phase locking protocol. And this transaction makes lock and unlock request in two phases. So two phases are there in which transaction can request lock and transaction can release lock. So first phase is a growing phase. So in growing phase, transaction may acquire locks but may not release any lock. Okay, so growing phase means transaction is growing for the execution, transaction is growing for the operation. Here transaction is requesting lock and transaction is acquiring lock. Okay, but there is no release of any of the locks. Also, if transaction want to perform upgrading of lock, then it is also possible in growing phase. Upgrading means changing of shared lock to exclusive lock. If transaction want to change the state of shared lock to exclusive lock, then it is also done in growing phase. Okay, and second phase is shrinking phase. As name suggests, in shrinking phase, transaction is going towards the end process. Okay, it means that transaction is releasing lock one by one in shrinking phase. But in shrinking phase, transaction cannot get any new lock. Okay, and downgrading of lock is done in shrinking phase. Means if transaction want to change the state of exclusive lock to shared lock, then it can be done in shrinking phase. So this is called two-phase locking protocol, which is mainly used to ensure serializability, but it does not give transaction a freedom from deadlock. Means using two-phase locking protocol, we cannot avoid deadlock situation. Okay. Now we have another type of locking protocol, that is strict two-phase locking protocol. Okay, so as we studied that two-phase locking protocol does not ensure freedom from deadlock. Okay, and two-phase locking protocol may cause cascading, abort or rollback operation. So to avoid these problems, we can use strict two-phase locking protocol. Okay, so in strict two-phase locking protocol, it is mainly used to ensure ensure that we don't have any cascading rollback in concurrent transaction execution. Okay, so in first step of strict two-phase locking protocol, transaction starts execution and request for the locks. So this first phase of strict two-phase locking protocol is same as that of two-phase locking protocol. Okay, but this strict two-phase locking protocol does not release any lock until transaction is completed. See, in simple two-phase locking protocol, that protocol releases lock immediately after use. Okay, once two-phase locking protocol has finished its execution with any lock, then it will release that lock. Okay, but strict two-phase locking protocol does not release any lock until the transaction is completed. It does not release lock immediately after use. This is the difference between two-phase locking and strict two-phase locking. Okay, strict two-phase locking does not have any shrinking phase. Okay, since this protocol is not releasing any lock until the transaction completion, there is no shrinking phase in strict two-phase locking protocol. That is, transaction can request for locks any time until it is completed. In two-phase locking protocol, transaction releases a lock immediately after use, and after release of first lock, transaction could not get any new lock. But this is not the case in strict two-phase locking. Here, transaction is releasing lock at the end of transaction. Okay, so it may request for lock anytime until it is completed. Okay, so this is the difference. In strict two-phase locking, all unlock requests appear at the end of transaction. At the end of transaction, strict two-phase locking is releasing all the locks. Okay, and since strict two-phase locking does not release lock until the end of transaction, there is no situation of cascading rollback. Okay, so this is the strict two-phase locking protocol. Now we'll see what is the difference between two-phase locking and strict two-phase locking by one example. So here again we have two transaction, T1 transaction which is following two-phase locking protocol and T2 transaction which is following strict two-phase locking protocol. The example is same, that is both are working with data item A and data item B, but both transactions are following different protocols. Okay. So here T1 transaction is having exclusive lock on data item A and data item B, and T1 is following two-phase locking protocol. At time cycle 6, T1 has released lock on A. Okay, see at time cycle 6 you can see that T1 is having unlock instruction for data item A. Means T1 is releasing the lock on data item A. Okay, so this is the starting of shrinking phase of T1 transaction. Okay, and at cycle 10 T1 has released lock on data item B. Okay, means here T1 is releasing lock immediately after use. So this is called two-phase locking protocol. Okay. Okay, so at time cycle 10, T1 is releasing lock on B because now it has finished its work with lock that is held on data item B. Okay, whereas transaction T2 is also holding same locks, exclusive locks on transaction on data item A and B, and T2 is following strict two-phase locking protocol. Okay, but T2 does not release lock immediately after use. Instead, T2 is waiting till the completion of transaction and then releases both the lock. As you look at the execution of transaction T2, you can see that at time cycle 9 and 10, T2 is releasing both the locks. At time cycle 9 and 10, T2 is having unlock instruction for data item A and data item B. Okay. So the difference is that in T1 transaction which is following two-phase locking protocol, it is releasing lock immediately after use, whereas T2 which is following strict two-phase locking protocol, it is releasing all locks at the end of transaction. Okay, so T2 is ensuring a freedom from deadlock situation. Okay, so this is all about locked base protocol, two-phase locking protocol and strict two-phase locking protocol. Thank you.